today by Dr. Joe Handelsmann and Kendall Lamkey. Dr. Lamkey, who you all know. Joe is the director for Wisconsin Institute for Discovery. What makes her somewhat unique is that she was the former associate director for science at the White House Office of Science and Technology Policy. She's also a Willis Research Professor and Howard Hughes Medical Institute Professor. She received the Presidential Award for Excellence in Science, Mathematics, and Engineering Mentoring from President Obama in 2011, and was inducted into the American Academy of Arts and Sciences in 2019. Currently, she's on the U of W faculty and previously was on the Yale faculty. And I think I'm going to try to figure out how to share screen.
I don't need to share, so don't worry about it.
I will try to share mine though.
Oh, sorry.
That's all right. That's okay. Kendall was saying we should have figured out how to run this yet.
Yeah.
There we go. So I'm assuming the screen is visible now.
Yep.
If not, let me know. Okay, so why three presenters? As we look forward to see what's going to happen in the area of soil science and soil science research, there are various individuals or groups that will have an impact on how these decisions are made. There's the I don't want to say the upper level, but the political world that will have an impact on funding and vision. And Joe has been in this world. And so we're going to ask her to discuss her personal experiences as it relates to soil science and see if she can give us her vision of what's happening in the future. And she's also writing a book. I'm hoping she will tell us a little bit about the book she's writing. Dr. Lamkey has a vision of soil science as it relates to us in a more local situation, and that he's managed the department for what, since 2007, I think it is. He's managed the department through fast water, slow water, rough water, calm water. In spite of dominating most of his career in at least a major part of it in administration, has over 80 publications at this time, which I think speaks loudly of what he's contributed to and for us. And if there's any time left over, and actually I hope that Kendall and Joe fill the time slot with their stories and ideas. We'll talk about my vision of where research is and where it's going in the future. So with that, I'm going to ask Joe to take over and give us your vision of what you've experienced and where you think we're headed in the future in soils.
Well, thank you very much, Rick. It's a pleasure to be here. I used to love visiting Iowa. I think it's my most visited campus, and so it's a shame I'm not there in person, but maybe someday again we'll get to visit you guys. So I was a science advisor to the President Obama for 3 years. And during that time, I had several what I thought were very successful initiatives of new programs, new developments, like the precision medicine initiative that President Obama and I launched in a shared way. I was very interested in it, but it turned out that he already had a very strong interest in genomics. And so we got together and developed the precision medicine initiative. And the thrill of hearing the words that I had written come out of his mouth in the State of the Union address of 2015 was probably one of the most exciting moments I had in the White House. And he carried that initiative through right to the end of the administration, when legislation was passed 92-8 in the Senate, which, if you remember what 2016 was like in the Senate, not very cooperative, but that initiative got incredible bipartisan support, and that was partly due to Obama and partly due to just the nature of the initiative. So I had had very successful initiatives on various topics, including some in agriculture. And the one that I had just a terrible time getting traction on was soil preservation and soil science. And it was very hard to get anything done in agriculture because there are a lot of very powerful factions in our society that control and influence decisions in Washington about agriculture. But there was nothing like soil, where I was just stymied from so many different directions. So that's, Rick mentioned I'm writing a book. That was my motivation for the book, was just being essentially blocked from developing policy. We did have a soil initiative, which was not a presidential initiative. It was just a White House initiative, which means that there was a little less fanfare about it. But we never really got USDA, which is, of course, one of the big influences strongly behind us. And so and since I left the White House, I can say and do what I want, which was one of the things that really frustrated me in the White House, is you can't say what you want unless it's official White House policy. As a senior level Senate appointed, Senate confirmed appointee. So I had to watch what I said at all times. But now I can say whatever I want. It took me a while to get used to being in academia again so that I could talk again. But now I'm very blunt about my opinions. And one that I am trying to promulgate across the world, not just the US, is that our very top priority in agriculture and the environment, along with climate change and integrated into climate change, should be the preservation of soil, particularly by increasing soil carbon. And if we increase soil carbon across the world, it could have, if we do enough of it, a pretty substantial impact on greenhouse gas concentrations and ultimately emissions. So I think that this is one of those no-brainer kinds of decisions because there are no downsides to the outcome. There are two really, really powerful upsides. If we don't take action on soil as both a country and as a world, we're going to be losing our soil so unbelievably rapidly over the next decades that many countries will simply not be able to feed themselves anymore, or will be less able to for those who can't at this point, because they simply won't have fertile cropland. It's going to take the United States a while to get there, but we already see the loss of soil and the exposure of subsoil across various areas, Iowa being my favorite example, but there are other areas in the country where there isn't sufficient topsoil to grow crops, or the yields are beginning to drop because of the loss of topsoil. We think we've lost about half of our soil. This is a very rough estimate. It's obviously impossible to say, but we've probably lost about half of our soil and a quarter of our carbon in soil since about 1850. And if we were to restore that quarter of our soil carbon, we would make a gigantic stride toward eliminating climate change. In fact, we could bring the concentrations of greenhouse gases close to where they were when the Industrial Revolution started. So to me, that should be our goal, because it would solve two enormous problems. It would bring our soil health back to where it was 170 years ago, at least in terms of carbon and lack of erodibility. But it would also have this tremendous effect on climate change slowing down. So that's just my perspective and my sort of big goals. And then we have to think about, of course, policy. How do we accomplish something like that? Well, an initiative was proposed in 2016 in the 2016 Paris climate talks. It was brought forward by the French and signed on by 29 countries who all agreed to increase soil carbon by 0.4%. And so it was called 4 per mil or 4 per thousand. It was the name of the initiative. And if we raised soil carbon across the world 0.4%, that would be sufficient to negate any increases or the predicted increases in greenhouse gas emissions over the next decade, which is going to be really critical to the sustaining the Earth's current biological functions. And so that was a really exciting proposal, but the United States didn't sign on to that. And when I talked to people at USDA and the Secretary of Ag and people in the White House, the objections were several, but one was that it's not an attainable goal. And that was intended from the very beginning. It was intended to be an aspirational goal, something that we might head toward or hope for, but we would obviously not reach it. But the United States took a much more pragmatic view and said, if we don't have the metrics and we don't have the goal as a feasible one, then we don't want to be involved. So I think that one of the first actions of the Biden administration should be to reignite the 4 per mil concept, maybe call it something different, because now 4 per mil has all sorts of connotations in some countries that are negative. I think it should be narrowed to be 4 per mil in agricultural soil, because one of the reasons that it was an unattainable goal was that it pertained to all the soils across the world, which of course is silly because there are many, many, many soils, and millions, if not billions of hectares of soil that we have no way to control. We have no way to increase their carbon. So if we focused in on agricultural soils, did some calculations to figure out how many hectares that would be, how much soil carbon we could increase, and then what that would do to both soil health and climate change, I think we would be in much better shape in terms of getting worldwide support for this. So that's something I really hope that the United States will lead. And I'm working on people in the White House to put that forward to President Biden. In addition to making that international goal, we obviously, if we're going to advocate for that, we need to be on board with it as a country and try to achieve it. We know how to increase soil carbon, and it's actually a pretty rapid process given the geologic nature of soil, that it takes so long to form soil. Soil carbon is actually relatively easy to increase. And so if we were simply to change farming practices across the country to increase use of no-till farming, increase use of compost for certain crops that's feasible, increase the use of intercropping with deep-rooted prairie plants that enrich the carbon quite rapidly, and increase cover crops to prevent soil loss in the non-crop time of year, and then also to increase soil carbon. We could bring soil erosion to a halt in a few years if that were those practices were implemented across cropland in the US. So the question is, how do we do that, and why can't we do it? Why haven't we done it already? And of course, a lot of it comes down to finances. And so we need to make those practices incentivized for farmers so that it doesn't cost the farmers to change their practices. If a farmer is already invested in practices, there are both emotional reasons, like people, I've heard them say it myself. I've always done it this way. My dad already always did it this way, and I'm not going to change my practices. Okay, so that's some of it. We have to deal with that at a more emotional level. But we also need to make it financially feasible. And so the strategies that I think could really influence this are, first of all, crop insurance, which farmers have and currently actually disincentivizes certain practices that would preserve soil. So we have to get rid of that absolutely perverse disincentive process. But then we also need to incentivize the practices we want to see. And so if we could institute something like soil insurance or crop insurance that is backed up by soil, where farmers' rates would go way down and their the cost of the insurance would be reduced proportional to how much soil carbon they incorporated, we could completely change the arithmetic for soil carbon. Another idea is to make soil carbon something that we label food for. So for example, having a soil safe label, or in my more radical moments, I think we should call it something more like produced by carbon heroes, because I think this country needs to much more powerfully recognize the heroes that farmers are and what they do for us in terms of feeding millions of people, but also the power they have over our environment and their ability to help us fight climate change. And so if people would get engaged in that, just like they have in organic labels and other kinds of no antibiotic food and various other labels that have been invested in by consumers, we could then make sure that the profits, the increased profits from those foods, would be fed back to the farmers and would pay for their ability to transition to soil safe practices. Those are just a few ideas. I think I'll stop there, and we can go back to any of the ideas that I've brought up and some of the challenges to implementing those ideas. But with that, I'll turn it over to Kendall.
There we go. Come unmuted. I'm ready. Well, thanks, Joe. That was very interesting. I want to talk at a little different level about this, because I'm going to talk about the department, of course. And I want to first tell a story I told last night. Last evening, I'm the chair of the AppSim Steering Committee, which is the modeling platform that we belong to as a department out of Australia. And we were looking at the strategic future of that farming systems model. And the story I want to tell is, so back in 2019, I just want to tell this story because I think it's kind of important to how we evolve what we're doing. 2019, former President Trump tweeted a photo of a military establishment in Iran. And you probably wonder what that has to do with anything. I just happened to see it on Twitter, and this may not be a true story, but it's still on Twitter, this analysis. And then a physicist or astronomer in the Netherlands analyzed the photo. And they figured out, it came from a low-level spy satellite that the U.S. owns. And it turns, they don't publish the orbits of these things, but but amateur astronomers follow it. And so this astronomer analyzed the photo, and it turns out the satellite's about 260 kilometers above the Earth, and it took a 10 centimeter per resolution photo. And stuff right now, that people are, we can do it, right? But you got to do it with drones, and you can do it with airplanes too. My point about that is that, the capabilities there now. She actually thought the resolution was 1.5 times better than that. So this stuff's capable. And I think it's going to influence a lot of what we do as we move forward in departments like ours, because we're going to be able to see everything, right? I mean, at that resolution and with enough of these satellites, they'll soon be in commercial use. And so I just think about that, because I think there's a tendency sometimes for us to bet against technology. I've actually, as a plant breeder, have betted against technology and lost that bet. And so we won't go there first thing. So I think the future, for us, So I think our challenge is going to be doing what I call balancing blue sky research with science that directly impacts production systems. I think this gets at some of the things that Joe was just talking about. So I'll just kind of go through my little short spiel, and then you guys can tear it apart. I think the future is going to have to increasingly take a look at and take a systems approach to its analysis. And there's different levels of systems approaches. And, we've been, a lot of folks in the department using various models. The modeling platform doesn't matter to me so much as long as we're using some kind of systems approach. The systems approach brings in a multidisciplinary approach, which we haven't always had in the academy in the way we look at these things. But the AppSim modeling platform, it's a collection of models, really just embraces mostly what we do in agronomy in our department, weather, soils, plants, and genetics a little bit. The genetics part still hasn't been worked out very well on that. There's folks working on that. But there's also different And I think we need to continue with this kind of approach to advance our science and understanding the biophysical relationships in farming systems. I personally think we've learned more in the last 10 or 15 years about what's going on in Iowa than we learned previously. But we know a lot. I'm not saying we don't know a lot, but we've learned a lot too. I think changing what's actually done in farmers' fields, to Joe's point, is going to take a complex systems analysis approach that's probably beyond what we can do in agronomy. It's one of these problems where, if you push here, something bulges over here and no one thought about it because we didn't look at it. And I think that may, I'm going to venture to say that may have to be done outside the academy. That's one of the things that worries me, because we're not always set up here to do these things well. I'm not saying we can't get set up to do it well. It's just been difficult, right? And so, but we may be able to form that approach as we move forward. You're probably thinking this is not looking good. It will. So I think our soils program in agronomy, I'll get to there. I'm going to stay really general here. It needs to maintain 3 kinds of deep discovery, blue sky research, I'm going to call it. Some people want to call this basic research, but I don't like that word. And I'm just going to call it deep discovery, blue sky research in biology, chemistry, and physics. I think these are the 3 areas you need to do. It's going to be multidisciplinary driven. How these 3 levels of discovery are focused will be important. I'm not the one that'll be determining that, but I think there are some parameters on it that will. I think some of the focus of this has got to come out of the systems modeling that we use to help drive where the future discoveries should be looked at, right? The things that are really impacting the system. And then a lot of it's going to be determined by funding. And I think this is one of our challenges as we move forward in agriculture in general, is that the U.S., so now I'm going to state an opinion. These are all opinions, but this one's a really out there one. The U.S. research enterprise is broken, in my humble opinion. And, but, we'll have a discussion about that another time. I think we also need to maintain a significant presence as a department in innovative practice, application, and extension. And the question is what does that look like for the future? What will be the balance between research and extension? And what will extension look like in the future? I think it's going to change a lot in how we do this over time. I mean, there could come a day when, most of what agronomists do is done in a room from observations that people are making from satellites and from other instruments that farmers may have on their fields. I think it is going to advance that way. And some things that I think about, more specifically, is like nutrient management. I mean, we're going through an evolution of nutrient management. What will it look like 10 years from now? And I think that's the sort of way we need to be thinking about applied soil physics, soil conservation, erosion, tillage. Some of you work in these areas, digital soil mapping. Dr. Miller there, I'm looking at you. And how's that relevant to crop production? The systems modeling we've done so far show that groundwater dynamics is the top driver of the production system. One of the top drivers. That's an overstatement, but it's a key thing that we got to know. We don't know very much about it. Remote sensing, which I've already been talking about. I think that we need to integrate all this into our undergraduate program. I'd like to keep reminding us that the most important thing we do is educate undergrads, because they're the ones who are going to be going out and doing the stuff that Joe wants done. They're the future, and how they think about stuff is really, really important. How graduate students think about it is important too, but there's fewer of you than undergrads mostly. And then finally, I want to just leave you with how we hire is really important. We need to hire people for not what they've accomplished, but for what their ability to innovate for the future and to think differently than we've been thinking. And that we may need to hire outside our traditional disciplines. I think this is for me as a plant breeder, it'd be like heterosis, right? Type of thing. But because sometimes the change comes from the edges, right? Well, it doesn't always, but the folks who are out there thinking about stuff in ways that we've never thought about. So I'll just leave it at that. And that's pretty general, but if I get really specific, I'll get myself in trouble.
Hey, thanks, Kendall, and thanks, Joe. I'm going to address a few items that I've been thinking about since Bradley asked me to do this. The soils research, I've been around quite a while. I've had a lot of birthdays and watched soils research grow or change. And I would break our soils research as it occurred into different phases, starting with simple and getting more complex. I think when we started in the soils research arena, we had fairly simple studies, one-dimensional, looking at things point in time. Then we moved on to relational research, compound, where you're looking at how things work together. And we went to complex systems where we're dealing with multiple dependent and multiple independent variables, trying to make sense of the complexity that exists. And we're moving into the area, and Kendall, excuse me, alluded to it, of complex and dynamic. And that simply suggests that we're addressing how complex relationships and their interactions change with time. This is a multi-dimensional study, and it's a type of study that requires different tools than we've used in the past, different skill sets. We've had throughout the multiple decades that I've been involved with and look backwards, theory and theoretical based and conceptual based research approaches. So just a little bit more detail about these and what do I mean. When I talk about the simple phase, static in space and time, one-dimensional, we're basically dealing with soils research in the past on basic building blocks, addressing pH, soil structure, individual items, soil health parameters. You go back to the literature and you find titles such as soil property effects on such and such, or how such and such affects soil properties. Then we moved into the variable in space or time, which I've identified as complex. The types of things we addressed here were soil organic matter with depth, tillage, cropping systems, conductivities across field, seasonal change in soil erodibility. And as we move to the complex and dynamic, and I say that's where I think we are now. And these things mold together. We're not strictly looking at one of these at a given time. But I say we're looking at four-dimensional challenges, and that we're dealing with length, width, if you're looking at a landscape, depth, soils have depth, and the complex nature of this comes in as time. These research approaches are data intensive, and they have spatial and temporal resolution considerations. We haven't had the computational capacity to address these types of studies with the data needs that exist today. And we've used the analytical solutions, numerical approximations to complex soil processes, the types of things that we typically see in soil chemistry, soil physics. We've used those in deriving these solutions that we're approaching in the spatial different resolutions, multiple resolutions, and more importantly, in the multiple dimensions. So what types of things in broader categories are we looking at today? When some of us started, I'll use myself as an example. Those of us in soil science had 1 foot in a laboratory or in a greenhouse and the other one on a John Deere tractor. We are more than ag systems approach or ag systems focused and oriented today. We're a much different soil science research group than we were once upon a time. We bridge across multiple professions, multiple interests. And I take these thematic research areas from a paper that was published in the Soil Science Society of American Journal. I think it was 2014. In fact, as I've highlighted below, 2 individuals with Iowa State backgrounds. Bradley Miller is one, Colby Mollberg is another, where they've broken future research agendas into different thematic areas, as you've identified here. Soils as a key regulator of ecosystem functions. This bridges across many different areas and categories of research, sciences. When I started this work, 1970s, 1980s, I wouldn't have thought of having soils be involved with something like the IPCC report. Soils are increasingly recognized, and I struggle a bit when I hear Joe saying that getting soils recognized at the presidential or that administrative level. I struggle when that can't happen. Although I do remember one story she told me. She had said one of her most proud moments was when she got Barack Obama to call dirt soil rather than dirt. So there's an element of recognition there. Soil's role in public health and human well-being. These are areas, as Kendall mentioned, going to be cross-disciplinary, transdisciplinary. Soils mediating nutrient cycling, transport processes, plant, soil microbial interactions. These typically fall, in my mind, in the area where we've been working in ag, soil formation and degradation. If we're going to meet some of the goals, again, as Joe had mentioned, adding carbon, changing soil, what it is. Soil degradation is a critical element, whether you're dealing with FAO in the UN, internationally, or even locally. How fast is soil degrading? And is it forming at a rate that will not be compromised that our current rate of degradation is? And the big one, in my mind, is soil information systems. You say, what are soil information systems? Well, we have been operating as we try to address a lot of solutions using false assumptions about soils. We have assumed soils are discrete bodies with sharp boundaries, and we've also assumed that soils are static. Now, this is not a negative push on what the science has been. If we're going to take the step forward, we must understand that soils don't have sharp boundaries. If we're going to deal with precision management, precision conservation, precision application, we have to have a much better spatial resolution of the information that we have about soils. We have to have better temporal resolution about the dynamics that are occurring as soils change. Soils are living bodies. Soils change with time. There's anthropogenic effects, there's natural effects. We are using some very sophisticated models currently, and Kendall mentioned one, using APSIM. These sophisticated models, to give us the type of output that they have the capacity, require accurate inputs. When we've used traditional soil classification models, and assume we have discrete boundaries, we're not capturing the variability that occurs across the landscape, and we're typically not capturing the variability that occurs in time. The models that we're dealing with are simply spatially sensitive, they're temporally dynamic, and the information that we need has got to be sensitive to modeling needs. So I'm pushing to advance the type of work that Bradley Miller is doing, and I'm not trying to pick on him or even highlight him. But the needs that we have in soil science for improved basic information about soils, as most of us that are on this call or on this webinar, we're going to need that information. So that's my kick in terms of where I think we are headed or should be headed. And I'm going to open this up for questions now. And Laura, Bradley, you want to manage?
Sure, we'll have your back.
Good.
So I'll remind everyone that we certainly encourage you to speak in person, ask your question. If you're concerned about speaking over someone, you can raise your hand by opening the participant window. So the participant buttons across the bottom of the Zoom meeting, and you can raise your hand that way. Or if you prefer just to type your question, we'll be happy to read your question for you. You can type your question in the chat. While people are thinking about their question and overcoming their shyness, Mario Casey brought to my attention a paper that he just recently published with Rattan Lal regarding aligning science and policy of regenerative agriculture. And I think that really expands upon quite a few of the topics that were brought up today. So I'll encourage you to check that out.
Mike's got his hand up. Mike Castellano.
Oh yeah, thanks, Rick. Yeah, I've got a question, probably mostly for Joe, and related to the idea that the 4 per mil concept was aspirational and perhaps never achievable, certainly across all soils. Another one of these aspirational goals that I can think of is the 45% target in nitrate or hypoxia size reduction in the Gulf of Mexico from 2001 to 2015. Again, I think that's clearly was an aspirational goal. We didn't even come close to it. In fact, it's bigger than it was, and we've kicked the can down the road with that aspirational goal. How do we balance using aspirational goals, given their power and simplicity, with the the fact that the taxpayers want a result, and people will potentially stop believing scientists if we make these aspirational goals. We don't properly make the public aware of them, and we never even come close to achieving them.
I think it's a great question because aspirational goals can be very inspiring, but they also can be misleading. Within the field, they may be inspiring and we know we're not going to reach them, but outside the field, the public can say, well, that would be great if we could do that, but then they don't know the limitations. So I think it's probably better, from what I've seen, to stick with goals that can be achieved or closer to goals. If in the Gulf of Mexico, they had said, we're just going to turn hypoxia around and start decreasing it rather than increasing it, and they'd achieved that goal, that would be gigantic compared to where they are. I don't think anyone suspected that they would be as unable or incompetent, I'm not sure what the answer is, to turn it around as they've been, but I've seen estimates that they'd have to increase the investment to billions of dollars rather than millions in order to achieve it. So some of it is we have these big goals, but then we can't get Congress to invest in them. And that, I think, often is a problem. I think soil erosion is a great example. We did have great goals, and we started to achieve them back in the 1980s based on the Food Security Act. And then slowly over the next few farm bills, Congress just eroded our ability by cutting the funding, and we have no accountability now on soil management. And so I think that's one of the challenges is, the public says, well, I thought you fixed this in the 1980s. What happened here? Why haven't you fixed it? Well, if you cut our funding, we can't fix it. I think some that have actually have worked, and it would be very interesting if a sociologist has studied why, is the war on poverty and the war on cancer that were both implemented a long time ago. And they maintained their cachet with the public for quite a long time. Only recently have people started saying, like when Biden launched his moonshot on cancer, I heard a lot of people say, wait a minute, back in the 60s, Lyndon Johnson was talking about the war on cancer. Why haven't we done this already? How many times are we going to raise the same goal? And but it took a long time for people to feel that we weren't reaching the goal and we were repeatedly posing the same goal. Why that is, I don't know. If that's perhaps a human health versus agriculture issue, and people are just more impatient with agricultural goals and environmental goals. But that might be something to look at, is why that one was okay with people. Of course, we're not going to cure cancer completely. We're not going to eliminate cancer. That's absurd. But the public fell for it and didn't resent the fact that we couldn't attain it.
Thanks.
Gainer.
Hello. Thank you so much for your talks. It was really mind-opening. And I totally agree that we have to use digital soil mapping, GIS, remote sensing to find solutions for carbon stocks and agriculture. But my question is regarding that. So we need computational powers to be able to accomplish that, like quantum computers are being launched. And how about like the departments in the US? Are you guys thinking to invest on computational power, computing power in the next following years? What do you guys think about that?
Who is that directed at?
I couldn't hear Dr. Cruse. Could you repeat, please?
Yeah, who is that question directed to?
To all of you, whoever wants to answer.
Kendall, what's your take on the computational abilities in the department and where we're headed?
Well, I mean, I think there's a lot of opinions about that, you know, and so, you know, so we've had really good, I'd say, relatively speaking, decent computational capabilities in say, in climate and weather data, meteorology. I mean, it hasn't been awesome, but it's been pretty good, right? And you know, and then our other big investment in this arena has been in the genomics area. And I think the challenge has been, and I think the cloud's going to straighten some of this out, but I don't know if the cost will come down. The challenge has been is that different kinds of computation take different kinds of machines. Bradley, we've had some success. It hasn't been fast. He won't say that. He's smiling. You know, we got Bradley set up computationally too. I agree. Computations is a big problem for institutions like ours, Channer, and I think it's going to be really, really important that we solve those problems. We'll have computational challenges as well with running these models at scale. We got to continue working on that. Whoever wins the computational war is going to win some of the grant dollars, not all of them, but some of them.
My office at the White House launched the quantum science initiative and quantum information science initiative. And one of the things that frustrated me was every time we had a meeting, we had a bunch of physicists and engineers. We never had the users of the high capacity computing at the table. And agriculture was certainly one of the areas that I thought needed to be represented. And the Department of Energy, surprisingly, in their ARPA-E, which was the very high risk and high yield research area for energy, but it ended up being a lot of agriculture work, including soil. They were talking about it, but we couldn't somehow introduce that into the really high throughput computing development conversations. So this is something I saw at the White House repeatedly, is that agriculture was just dropped out of certain conversations. And I think we have to make ourselves much more prominent and persistent and annoying and get ourselves at the table when these things are being discussed.
Marshall.
Thanks everyone for sharing your experience and thoughts. There's a lot of interest in the emerging carbon markets. And you know there's a lot of interest in something, right, when you see it at the pillars of journalism and, you know, the New York Times and Wall Street Journal, all the way down to farm magazines, right? So I was wondering if each of you would tell me something you're excited about the carbon markets, and then something you might be worried about them. And I
Okay,
want Rick to go first.
yeah, oh, I'll go first and I'll let them correct me. The potential to get farmers engaged in a world of carbon and regenerative, not I don't say regenerative, but improving carbon stocks is the first step for soil health. That's exciting to me. What really troubles me immensely is that everything that can be gained in the carbon market for that reason, in terms of raising carbon stocks in soils, can be destroyed or lost in one season. And how we're going to handle that, I do not know. That's the flip side of the carbon market that no one's talking about.
There's a lot that's been written about the problems with carbon credits and the monetary assignments to soil carbon. And I don't completely understand all the arguments. So one that comes up over and over is the nonlinear relationship between fixed carbon and emissions. It's not a one-to-one relationship, that you have, 1 ton of carbon in the soil that immediately translates into 1 ton less in the atmosphere. So that's, to me, a kind of a calculation issue, and the way that we credit the carbon and can be solved. But that's one that I've heard a lot. One of the things I think is great about the carbon markets is that just by getting agriculture at the table, people begin to realize that carbon is an agricultural issue in part. And one of the arguments that I keep being amazed at is how agriculture is apart from the carbon discussions. And people say, well, yeah, sure, agriculture uses carbon and has carbon emissions, and they think of cows and tractors, and they're never thinking about how agriculture can take carbon out of the system. And Rick is right that the IPCC report has now begun to focus on soil. They had a special report, I think a year or 2 years ago, on land management and climate, but the public is still way behind. And so I think anything we can do to highlight the role of farming and the powerful potential for farming to mitigate climate change would be just fantastic.
Kendall remains quiet, so let's go on to Bob Horton.
Thanks, guys. I have too many thoughts to fit into the 2-minute time slot that we have left. So I'll just hit a couple of highlights. One, maybe 10 years ago or so, Brian Hornbuckle, Mike Thompson, and I brainstormed a little bit about ideas for our graduate education program, thinking about the need to look at bringing some of these disciplines together that were mentioned, physics and chemistry and biology, and having some courses and a curriculum that looked at the whole soil rather than a curriculum that we have right now that partitions the soil into soil physics course or soil chemistry course like that. Somehow we need to come together in our thinking ourselves and our education of our students, thinking of the whole soil again. That's one comment. A second comment, I think it would be good if we can identify like a grand goal, and a couple have been presented by you guys, soil carbon, increasing soil carbon, for example, reducing soil erosion. These are like a couple, but what's like something grand that we could think about that would be larger than us at Iowa State University? Could be United States or could be the world, as you've talked about. And then, what does it take to really make some progress from a science perspective. What are the measurements, ground truthing sort of measurements that we need to make? What are things we can do on bigger scales, with space and time sort of things? What do we need to measure that we could put into models? What is it that we could think grand and big that we could do? And maybe in my mind, a soil health topic that's kind of getting some traction in vernacular right now. It cuts across physics, chemistry, biology, maybe more. Soil and it involves soil and plants, soil and climate, soil and health types of things. But somehow or another, we need somehow get the ball moving, get some momentum. We think about all this stuff on climate change. It kind of got rolling. It was identified as important, picked up, steam, and you can't turn around without bumping into somebody that's they're talking about climate change or global warming. We need to look for something like that that'll get some traction because it's important, not just make it up. And then, I think, what about, something like the human genome with NIH or the corn genome? We need to really say it's a big topic to really have soil properties and evaluate what's going on to, in terms of space and time, because it has to do with the health of people and the health of the environment. Okay, I talked way too long, but I think we need to do some brainstorming sessions in our department and think big. Thanks.
Thank you. Bradley, do we have time to hear from Ashley?
Yes, I think I'll just chime in and say I think as long as people are happy with the conversation and their schedules allow, we won't necessarily force the session to close, but respect anyone's schedule if they need to go. I'll just make my quick chime before people go that if you like this conversation, next week we're going to have the seminar look backwards for how we got here. So don't miss next week's presentation from Eric Brevik.
Ashley, you're up.
Hi, everybody. Sorry for keeping you late, but my question is directed towards Joe. And you touched earlier about prairie plants, and I'm particularly interested in restoration. And I was wondering if you could touch a little bit more on the positive and possibly even negative effects of planting prairie strips along our crop fields.
Well, you have probably the world's experts on strip cropping right there in your department. The STRIPS project was started to test that exactly. And some of the data are just stunning, where they've been able to cut down erosion by 95% in a single season by taking 10% of the corn out of production and replacing it with prairie strips. To me, that's one of the most dramatic results I've seen in science generally. I mean, we don't get those kinds of effects, but certainly not with soil erosion and agriculture broadly. So I think it's one of the most promising techniques. Unfortunately, one of those perverse disincentives I talked about plays into it, because if farmers take 10% of their land out of corn, they're going to end up with 10% less crop insurance. And that is so easy to fix theoretically. And I worked on that just about as hard as anything I did in the White House. And thanks to Rick Cruse, who told me to work on it. And it was verging on impossible to change that. And it's gonna take some. It was also late in the administration. So, I think if somebody started now with the Biden administration and got support from the top, I think that's a method that could really transform at least Midwestern agriculture.
Thank you so much.
Thanks, everybody. I don't see any more hands. I will mention today I saw Tom Vilsack's top for his 10 priority items. The second one had the word regenerative agriculture in it. I don't know what that means in terms of what they're thinking, but it's that was a plus. So Bradley, I'll turn this back over to you. You or Laura?
Sure. Well, just thank everyone for coming. Really had a great turnout. I think we mentioned to our presenters that we usually have like about 20 people, and we ended up with over 40. So thank you for everyone's enthusiasm, and let's keep it up through the semester because I think we do really have some great presentations, and this was a great way to kick it off. So thank you to the presenters. Have a great evening, everyone.
Thank you.
Thank you.
And everybody.
Thanks so much. That was exciting.
Thank you, Joe.
Yeah, Joe, special thanks, and you and Kendall both. We really appreciate the help.
Happy to do it anytime. Take care. Good to see you, Rick.
Yep, same here.